Hello and welcome to this presentation from CYP on our AV over IP solutions. My name's Dan, I'm a Key Account Manager for CYP UK and Europe, and today we're just going to cover a bit of an overview on some of our product lines. So let's move through into this presentation. You can see through here CYP are known for a wide range of products, ranging from, as you can see on display here, AV over IP, HD-Base-T and HDMI matrices, extenders, audio, switches, converters, signal management, cabling, commercial application, residential, medical, which is also coming up soon as a new avenue, and industrial as well. Today we'll be focusing on AV over IP. So we'll be working through an overview, then we'll be looking at our 1 gig solution, the IP7000 series. We'll be then looking at the SDVoE products, which are a 10 gig solution. As it says, the future is here. The future is now. It's called AV over IP. So essentially, AV over IP is the distribution of digital video audio and control across an IP network. We are seeing much more use of this now as it develops. HD-Base-T has been established for a long time. This gives an alternative depending on the solution, the application, and the situation required. So this covers AV over IP, covering video, audio, power, control signal, and USB functionality. Very handy for things like KVM or touch displays. This is all being utilized with a 1 gig network switch. And typical solutions for that, as you can see on here, would be things like, for example, retail outlets, using it for various signage. You can use this in a traditional matrix functionality. It can be used for video wall applications. There's a wide range of applications to use this with. There's a variety of codecs available with different AV over IP systems at the moment, and they are basically best to be chosen depending on the application. So some situations may require less bandwidth or lower bandwidth, but obviously reduced quality. Others may want to utilize the highest bandwidth of a system and include less latency and higher image quality. We'll get onto this a little bit further into the presentation. Let's have a look through at an example of the IP7000 series in use. This is a UK-based pub/entertainment facility in London, right near London's Tower Bridge. And this system here is running, it's just over 30 different screens, all being run through the IP7000 CYP AV over IP system. As you'll see on here, there's a wide range of screens around that property selected using our control system. So here's a bit of an overview of the system itself. So on the left-hand side, you can see there traditional transmitters, IP7000 transmitters. Our IP7000 transmitters have HDMI and VGA input and separate audio input as well for a mini jack connection, analog audio. So in this sort of system, plenty of transmitters. In this case, they're actually using satellite boxes for live sports. Those are all running into a 1 gig Ethernet network switch, and the controller is also plugged into the network switch, and then a series of receivers running from that network switch to the various screens around that location. In this example that we're talking about, this is the case study of a London sports bar. The actual system itself, I'll use the cursor here to display, but when customers come into this property through the main entrance here, just next to that main entrance for the staff to use is a touchscreen display that's connected to our IPCS7 controller with an HDMI connection for video and also a USB connection for the touchscreen functionality. So effectively, when a guest comes into this sports bar, they can speak to the staff, book a table, and then potentially select their sporting channel via the touchscreen. Again, the staff would do that, but that's all done through this location. And as I say, this system here, for an example, has around 30, just over 30 different screens running all through the one system. This is the touchscreen display. So again, on the right-hand side of this image there, you can see that's the CS7 control layout. That's the GUI. So what you're seeing here is effectively the transmitters on the left-hand side. In this case, that would be satellite boxes, Skybox is running sports channels. On the right hand side, you then got all of your receivers, all of your screens around the property. Now this can include single screens, groups of screens, or video walls. All of those can be displayed on the right hand side, and this is a drag and drop function. So if I wanted what looks like football there, I would simply drag the content across to a relevant screen and it would display that information on the screen. What you'll also see, this was just below that touchscreen. So again, this is the welcome area in this sports bar. This is one of our standard HD-based transmitters. In this case, it's a wall plate, and that is then being fed into the IP system. So it's a HD-based transmitter fed to an HD-based receiver, and that is then fed into the IP system. So if this location, this sports bar, if they wanted to run additional content into this device, maybe a laptop or something similar, it can be done at an easily accessible wall plate. You'll see on the right hand side of the screen here as well that they are running a video wall function, a video wall format, and we'll run through that in the next slide. So effectively all you're doing to create this video wall is assigning a selection of IP7000 receivers. In this case, you're running it as a 2x2 video wall. So you can basically set these 4 receivers in video wall format, assign them to top left, top right, bottom left, bottom right, and then that will be grouped. And when you go through on our on our display that we saw on the last screen, this would come up as a group of video wall. So one IP7000RX per screen, and then set this. You can save it in our preset recall on our system as a video wall, and then you would drag and drop the content to the video wall. And all 4 screens in this video wall would of course then show the correct content, the correct segment of the source that it's being fed. Another brand new feature for our phase 2 of our controller, which is now launched, it's now released and now shipping, is the multiple logins. So you can set this unit to be logged in as either an administrator or as another login on the system. So let's run through some examples here. You can see on this example there are 5 different zones. Zone 1, for example, may have a local screen, in this case maybe a projector, and it may have access to some of the transmitters. So as you see on the left here, you could set this that when a user logs in as Zone 1, you have predetermined what they have access to. So in this location, they may have only access to transmitter 1, TX1, and they would only have control and access to RX1, receiver 1, which is the receiver connected to this local screen. The reason for this, of course, is that this wider system, this AV over IP system, would be feeding all 5 of these meeting rooms or whatever room they might be. So of course, if you had standard login, the member using zone 2, for example, room 2, would be able to access the receiver in zone 1. And zone 1 might be in the middle of a meeting, and zone 2 accidentally put something different onto their screen. That just obviously, of course, is not acceptable in something like a meeting room situation. So that's why you would lock zone 1 with a bespoke login for zone 1, and it would only have access to the features and formats that you've allowed for it. If we go into example 2, an administrator could log in, would be able to then control any transmitter, any receiver, and have access to all of the settings. That would be someone, for example, that is managing this set of meeting rooms. Now, there are plenty of other examples here. You can see this sort of example we've given here. There are dividers in the middle of each room. So you might say actually zone 4 and zone 5 are going to be one master room. So you could have a login that is login 4/5, which would be rooms 4 and 5, and that would then have access to receiver 4, receiver 5, and whichever of the transmitters you've allowed it to have access to. And that, as I say, is very, very simple for the administrator to set up with login administration rights. Let's move through to the actual system itself. So you can see here, as I mentioned earlier, it is a drag and drop system. Simply drag any transmitter to any of the receivers, or this could also be video walls or groups of screens. What you see on screen now, this is actually the phase 2 version of our software, so it's a little bit nicer than the original version. Things like the settings have been moved to the bottom right hand side here. They used to be along the top, which was not quite as nice to look at and wasn't really needed for the end user. So the setup has now been moved to the bottom right hand side of the display. Monitor control is where you would have your transmitters and your receivers, and where you would do your drag and drop functionality. Preset recall. Preset recall is where you would bring back your presets. That could be, for example, preset 1 could be transmitter 1 to all receivers at one go, or preset 2 could be transmitter 1 to screens 5, 6, and 7, or something like that. You can set presets within the system that will allow you to recall them quicker. This can be then done through either on screen, or it could be done through a simple trigger pad, for example. We have a trigger designed to run with this system as well. Settings, I won't delve too far into that at this stage, we'll get back to that later, but there are various settings, of course, that can be run through with this unit. Devices, that will cover transmitters and receivers. Our old version of this firmware, you had to access things like the receiver or the transmitter individually to do updates or to make changes to it. Now, all of that information from every transmitter and every receiver is fed back to the controller, and that's what you're seeing on screen here. So transmitter 1, transmitter 2, and your various receivers, and you can then go through and change things like the routing of video, audio, USB, IR, or serial. We'll delve into that a little bit later as well. This one just going through, for example, options for audio. As I mentioned earlier, the IP7000 transmitters have an audio input, a separate analog audio input. So you may decide that this LG, as we've labeled it here, this LG screen, you want to have the video coming in from the laptop source, but you actually want to have the audio coming from the what we call pattern here, which would be a pattern generator. But you can basically say, I want the video from one source, but I want the audio from somewhere else. And that can be done with USB, IR, and serial as well. Looking into, this is one of the receiver screens. So this is showing you the receiver. And there are, as you can see, various settings on here, how you do free routing that I've just discussed, with the video, audio, USB, IR, and serial being available to route separately. You've got other features in here, for example, like the IP settings, video over IP. So you can set in here things like the scaler, for example, can be set in here, various other settings, which we would go through in a more detailed training on the system itself. This is then the transmitter again, so you can then look at transmitter settings all through the CS7 controller, so you don't have to log in separately to each transmitter or receiver. Settings download, again, we'll cover that in another video, another training video, but for now it just gives you a bit of an overview of the screen layout of the system. These sort of settings or system settings can be hidden from the end user. Again, that would be based on the user logins that I mentioned earlier, which, by the way, are found here, user. So an administrator would have access to the screen, but an end user, if you say they can't have access to it, then it would limit their access to these features. This here just gives you an idea of the layout. This is the case study that I mentioned earlier in the presentation, and this is using our RACS 600 rack. So this is a CYP racking system. The devices on the right hand side here are IP7000 products, so these are our AV over IP, AV over IP products. And on the left here we have some other smaller CYP devices that can still be fitted in with our blanking spaces inside. So again, all of this can be either RAC 600, or you can actually adapt smaller items to fit into our racking system. This here gives you an idea of the codec used for our AV over IP system. So it is using motion JPEG. So bandwidth you can see on here around 300 megabits per second. In terms of latency, latency is still relatively low, but it does vary depending on the frame rate. So there are options there as well. So there are ways, if you're approaching an incredibly high bandwidth, where you may then go beyond what the network switch or the system is capable of, there are ways to reduce that, to reduce the bandwidth so that you can still run the system effectively. That could be, for example, reducing the frame rate. And you'll see here the signal noise reduction. So that is their motion JPEG again, which is still very comparable with a lot of other systems and still incredibly good quality overall based on the sort of system that we're talking about here. So key features of this: flexibility and scalability. Of course, with an AV over IP system, if a customer has specified maybe an 8x8 originally, but then decides to add additional transmitters later on down the line, they can just purchase more transmitters. Unlike a fixed 8x8 or 10x10 or 6x6 matrix, once you've got that, that's the maximum you've got within reason. So with this, you can just add additional transmitters or receivers to the system. They're very, very simple to set up thanks to the wizard that's built into the CYP IP7000 CS7 controller. The control system, as you've seen on screen, and it's nicer when you see it in the flesh, but it is very, very simple to operate. The drag and drop works nice and effectively, and it's just really, really simple to use. The setup wizard I've already mentioned. Once you've actually plugged in all of your transmitters, receivers, and the controller into your network switch, you run the wizard, and it will take approximately 1 minute to locate all of those devices and have them ready to use. They can then be renamed as different room names, different transmitter names, etc., etc. Here's just a bit of a specification overview of the IP7000TX transmitter and the IP7000RX receiver. And here we go. This is then the CS7 controller. 1080p output. Obviously for a controller, it doesn't need a huge amount more than that. All of these devices will run with PoE as well, up to 100 meters either side of the network switch. Let's move on now to the 10 gig solution. So this case study here is from the Zurich Opera, and you can see the amount of displays being run in this environment. So this is actually a live theatre environment where the actors or performers on stage are filmed, and those images are then relayed to the live screens all around the premises. So of course for that you need incredibly low latency so that there doesn't appear to be lip sync issues, for example. This again highlights that with things like the actor being live on stage, but of course then being displayed on the live screens behind him. So again, SDVoE with its incredibly low latency just lends itself to that, so you can get a better performance. A very simple system diagram here: transmitters on the left, the SDV FTX, 10 gig network switch in the middle. This can be run through either fiber or CAT. The SDV CS8 controller, which operates in a very similar way to the controller we spoke about a few moments ago, and the SDV FRX receivers. We also have transceiver models available now, which can be used with this sort of system. So latency, as you can see there, under 0.1 milliseconds or 0.1 milliseconds. So very, very fast in terms of the performance, very low latency. Seamless switching is possible if you have this scaler engaged. Multi-view and picture-in-picture, which we'll cover shortly, drag and drop controller, and as you can see there, limited compression across most video formats. This is a control interface for it. It's a similar idea. There are more settings available with the SDVoE products. So instead of having tabs across the top as we did before, these are now running down the left-hand side. This is your main monitor and control. So again, transmitters on the left, receivers or groups. You can actually see that here, TV group, multi-view group, and you could have things like multi-window or video wall as well in there. The system and settings, again, very similar to the one we mentioned before in the previous controller, which was the CS7 controller. By the way, apologies, excuse that there. This is the CS8 controller, SDV CS8. These are just slightly older slides. That there is just simply where you can rename devices, for example, rename screens, rename transmitters. In here, this again, as we saw on the previous AV over IP, the 1 gig system, access to your transmitters and receivers separately, Again, adjusting things like the video, how RS-232 is routed, how the audio and other features are routed as well. And this sort of system gets upgraded quite regularly. Scaling is where it gets interesting. If your customer demands very, very fast switching times, what you would do is enable the scaler on the receiver. So if they want a certain room in a property to have almost lightning fast switching times, they would put on the scaler to match the screen. So it might be 4K 60, for example. If your screen will accept that, set the scaler at the RX, because effectively that handshake is already in place. When you switch from source to source, the switching time is incredibly low. So that is very, very handy for those that want almost instant switching. That doesn't affect any other receivers. You could have one zone, for example, with the fast switching, and then every other zone, if you want it to run natively to get the highest quality, like HDR, for example, you would have the scaler switched off in other zones, and they would then have maybe about sort of 3-second switching time, approximately 3 seconds. And then if you want to have the lightning fast switching, you would set the scaler to on for that relevant screen. This here, for example, is the video wall. So you can set a video wall with these. This is obviously on the right-hand side here showing a very large system. But again, all you would do is assign certain receivers into a video wall format and just configure it through here. It's very, very simple. And again, looks very good when you run that live. Multi-view is another nice feature. So on one receiver, so what you see on the right-hand side here, that could be one receiver, one display, displaying a variety of different screens, a variety of different sources. So in the middle here, you will see lots of different presets. So you can drag one of these presets to the right-hand side here, and then just populate any of these screens, any of these displays with a transmitter, with a source. So you would say, yes, I want this transmitter here, I want this transmitter here. And you can then watch multiple transmitters through one receiver. A popular or a typical example of that would be CCTV. So if you were looking to run a whole host of CCTV screens, you could do that all through one receiver, drawing in all of the information from a variety of transmitters. And as you'll see here, there's a whole host of presets available for that. So simple one by one, side by side, right the way through to many, many, many screens on display. So then we come on to the codec. So with the SDVoE system, obviously bandwidth is higher, which is part of the reason you can obtain a higher quality signal. And that's why you do then need to have a 10 gig network switch. So you will have a lot less compression on your 4K 60 video, for example. In terms of latency, incredibly low, depending on how you do it. Again, as I mentioned, you can either have the system set to fast switching, which would then include the scaler being on. So that would be your quicker switching times. But I say overall, the latency of the whole system is very, very low. And image performance is incredibly high, thanks to the fact that there is limited compression on the system. So the benefits of this system would be the flexibility and scalability again, exactly as we had with AV over IP. Add as many transmitters or receivers as you need at a later date, within reason, obviously within the capabilities of the network switch and the whole system. Very, very low latency, so almost zero latency, and lossless 4K 30. And the control system we've already spoken about, just the ease of use for the system. Here's an overview of some of our transmitters and receivers. These are standalone transmitter and receiver. And then these would be the transceiver models. So these can be assigned within the unit. They can be assigned as a transmitter or a receiver. And the model on the left here is a CAT version, so that would run with CAT cable. And the version on the right here is the fiber solution. And this is the SDV CS8 controller. And there we go. That's today's presentation for you. Just an overview of the CYP 1 gig AV over IP solution and 10 gig SDVoE solution. Both of these are available now, so please feel free to contact us at cypeurope.com for any additional information. My email address is on screen there as well for you, and we'll also have more of these presentations coming up in the future. Thank you again for joining, and I hope you've enjoyed the presentation.